example balancing the equation we wrote, this combustion reaction. So most of you guys are going to see this 2 here. And so you're going to put a 2 in front of the CO2. And then you're going to see that your hydrogens are balanced, but then you're going to look at your oxygens and see that you've got 3 over here and 2 over here. So I would put a 2 here first so that this can be an even number of oxygens. But then this also messes up your hydrogens. So it's going to make you have to put a 2 here. So then you have to change this to a 4. And then you've got 8, 10 oxygens. And then so you have to put a 5 there. Okay, so that should be balanced. So then the first thing you're going to do is figure out which one's the limiting reactant. So remember, you start with the masses you have for each one. I like to put those on my equation so I know what I'm doing. So I've got 5.80 grams of that one, and then 14.8 grams of this one. So then I've got to change those both over to moles. Okay, so put this over 1, and then you're going to look up the mass and add that up of C2H2. Okay, so then plug that in, and that will convert it to moles for you. Okay, and then same thing with the other one. Okay, and then divide that one by the mass. Okay, so I got 0.44 or 464. Remember, the second step is to go back to your problem, your equation, and figure out what the coefficient was and divide by that. So I'm going to divide that first one by 2. And I'm going to divide the second one by 5, the oxygen by 5, because that's its coefficient. So when you started out on this problem, you might have thought, well, you got a lot of oxygen, and you don't have very much of the C2H2. So probably, that C2H2 is going to be the limiting reactant. But then when you do this math here, you're going to see that it's not. If you plug this one in, I get 0.22. Nope, that was the other one, 0.112. And with this one, I get 0.0928. All right, so this one is smaller. This is my limiting reactant. All right, so you should circle that. Write LR out there. Put a big circle around that. That is the most important step to pick the right limiting reactant, because if you pick the wrong one, you're going to do the rest of the problem wrong. because you're going to start with the wrong number each time. So now the rest of the time, I'm going to start each of the problems with this number. All right, step 3, I already did that. I did that up here because I don't like to rewrite everything. Okay, so skipping down to 4, I'm going to determine how much of the products I'm going to make. I've got 2 products in this one, unlike the last one. So now I have to find 2 different ones. One of my products was combustion, so one of them is carbon dioxide. And there was the 4 for the coefficient there. Remember, it's 5 for the coefficient for the oxygen. So I'll do 5. And then the 4. Underline it. And then I'm going to change that to grams. I want my 1 mole on the bottom so it cancels. And then the mass of carbon dioxide on the top, which is 44 grams. Remember, that's just off the periodic table. You're going to add up 2 oxygens and add a carbon to it. So 16 times 2 plus 12. And then if you plug that in, I got 1.63 times 10 to the first grams of CO2. Still doing sig fig scientific notation and all the labels. This one I've got 2 products, so I'm going to start with this again. But now, so the first part of it's going to be the same. Over 1. Oops, I'm going to put the 5 moles on the bottom since I'm still trying to get that to cancel on this one. But now I'm going to go to my other product, which is water. And it's going to be 2 moles up on top. Oops. Underline it. All right, and then change the moles to grams. So again, look at the periodic table, add it up. So the number of steps you have here just depends on how many different products you have. Since I have 2 products, I have to find both of them. With this one, I get 3.34 times 10 to the 0. And then I've got one more step to figure out how much of the excess reactant I have left over. Still starting with the same number as the last one. So it's still going to be over 1, and my next step here is still to put the 5 moles O2. Well, kind of redundant, kind of the same thing over and over. But then up here, I want my excess, and I can't remember what the coefficient was. So that's 2 moles of this one. And then just like the other ones, you have to change this one to grams also. That's 26 grams. This, remember, is going to tell me how much that I'm using. And then I have to go back to the problem and subtract the number that they gave me. When I plug this in, I got 4.83. And then if I go back up here, I think it was 5 point something. Yeah, I started with this much. All right, so if you subtract those two, you get 0.97 grams C2H2. That's how much you have extra or left over.